Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening, children. Good evening. Good evening. I don't know if Anantika is facing any internet issues or something, but I even texted her personally, but it's not delivered. So looks like she has some network issue. So we'll start. Have you all completed the questions, answering the questions which I had posted?
Yes, ma'am.
No, ma'am. Yeah, ma'am.
Okay, fine. Okay, so ignore the question here. We'll discuss the answers to the one which I had posted. Okay, so the first question, let me take my mobile. Yeah. Yes, Sai Smriti, what's the answer for the first one? Additive inverse.
Yes, ma'am. 7 by 10.
The additive inverse of 7 by minus 10 is 7 by 10.
7 by 10. Yes,
Correct, 7 by 10. Correct. The next
and
one,
the next
Sai
one
Smriti?
is minus 8 by 5.
Minus 8 by 5. Very good. The additive inverse of 8 by 5 is minus 8 by 5. Correct. Next one, Shreya. Tell me the final answer first. Shreya?
7 by 4.
No?
Ma'am, I got minus 9 by 5.
Minus 9 by
5.
Sai Smriti.
Yes,
Okay, Shreya? Shreya, what's your answer?
7 by 4.
Okay, then others, Aishwarya Shri?
Ma'am, I got it as minus 9 by 5.
Minus 9 by 5. And Aishwarya
Minus
Shri?
9. Minus 19 by 5. 9 by 5.
Minus 9 by 5. Okay. Fine, let's see the correct answer. So you all have the question with you. You all have the question with you. So it's given that the sum of two rational numbers is minus 4. The sum of two rational numbers is minus 4, meaning one number plus the other number is equal to minus 4. Now, one of them is minus 11 by 5. So minus 11 by 5. One of them is minus 11 by 5 plus the other number, we'll call it x, is equal to minus 4. So x is equal to minus 4. And here minus 11 by 5, when transposed, it becomes plus 11 by 5. Minus 11 by 5, when transposed, becomes plus 11 by 5. So x is equal to common denominator. There's nothing here, so that means it's 1. 5 is the LCM. So 1 into 5. So into 5 here in the numerator. So minus 20 plus into 1. So into 1 here, 11. So x is equal to different signs in the numerator. Subtract and put the sign of the greater number. So minus 9. 20 and 11 on subtracting. The difference is 9. Greater number sign minus. So minus 9 by 5. So the other number is minus 9 by 5. Yeah, Shreya, you could make out your mistake.
Yes, ma'am.
Did you write that 4 as it is, minus 4 as it is?
Yes, ma'am.
Yeah, you must have written minus 4 plus 11, correct?
Yes, ma'am.
Okay. Take a screenshot and work this later. Or you can quickly write it now. Make a note of it now. I'll just wait for a minute. Those of you who have not presented it like this, kindly take down the working. It should be presented like this. You can start off saying, let the other number be x. You can include that. You can begin your answer with, let the other number be x. All right. I hope it's done. Made a note, children?
Yes, ma'am.
Yes, ma'am.
All right.
Yes.
All right, yeah. Yeah, the answer for the next one. Aishwarya. Aishwarya Shri.
Yes,
is
ma'am.
So yeah, not Aishwarya Shri. Aishwarya.
Yes, ma'am. I got the answer is 19 by 15.
19 by 15. Okay, what about Aishwarya Shri?
19 by 15.
19 by 15. The others, Shri and Sai Smriti?
Same, ma'am.
19 by 15, ma'am.
Very good. Okay. So the question is, what should be added to minus 3 by 5 to get 2 by 3? So let's say x is added. Let x be added. Let x be added. Okay. So what should be added to minus 3 by 5? Minus 3 by 5. What should be added to it? Okay. To get 2 by 3. So x is equal to 2 by 3 plus 3 by 5. Common denominator 15. So 3 into 5 is 15. So into 5 here. 5 into 3 is 15. So into 3 here. So 10 plus 9. X is equal to 19 by 15. So the number to be added is 19 by 15. Very good. Yeah, now Aishwarya Shri, what's the answer for the next one?
Minus 1 by 4, ma'am.
Minus 1 by 4. Okay. What about the others?
Yes, ma'am. Even I got minus 1 by 4.
Yeah,
Okay.
same, ma'am.
I also got minus 1 by 4.
Shreya?
Yeah, ma'am, the same one.
Okay, fine. So here it is, what number should be subtracted from? What should be subtracted from minus 3 by 4? So tell me, is it x minus, is it like this? Or is it minus 3 by 4 minus x?
Ma'am, I've written minus 3 by 4 minus x because it is from minus 3 by 4.
Correct, correct. Yeah, so it says what number should be subtracted from minus 3 by 4. So that's how we have learned it, right? That's the meaning conveyed. So whatever is after from should be written first. When it is subtraction, whatever comes after from must be written first. So from minus 3 by 4. So minus 3 by 4. First, what should be subtracted? So let x be subtracted to get minus 1 by 2. To get minus 1 by 2. So this is the equation. After from, we have minus 3 by 4. What should be subtracted from minus 3 by 4? So let x be subtracted. So after from, we have minus 3 by 4. So that first, minus x, let x be subtracted. And the result, the required result is minus 1 by 2. The required result is minus 1 by 2. So this is the equation. Now, you can transpose x to the right hand side, or you can even do this. Minus x is equal to minus 1 by 2 plus 3 by 4. Minus x, don't forget the minus here. So minus x is equal to minus 1 by 2 plus 3 by 4. Minus x is equal to LCM 4. So 2 into 2 into 2. So minus 2 plus this is into 1 here. 3. Minus x is equal to 1 by 4. Changing signs on both the sides. Changing the signs on both the sides. Minus x is equal to 1 by 4. So when you change the signs on both the sides, we get minus x, we make it plus x is equal to plus 1 by 4, we make it minus 1 by 4. So changing the signs on both the sides, we have x is equal to minus 1 by 4. All right, girls?
Yeah, ma'am.
Yes,
Okay.
ma'am.
Again, I'll wait for a minute just in case you want to take it down. You can. Okay. Next one. Okay, Sai Smriti, what is the multiplicative inverse of minus 3 by 4?
Hello, ma'am.
Yeah, Sai Smriti, multiplicative inverse of minus 3 by 4.
Minus 4 by 3.
Okay, minus 4 by 3, that's right. Aishwarya Shri, next one, multiplicative inverse of 11 by 4.
4 by 11.
4 by 11. Very good, correct. Next one, Shriya or Aishwarya. The product of two numbers is minus 8. One of them is minus 12. What's the other one?
From the other number is 2 by minus 3.
Yeah, ma'am.
2 by
Same.
3. 2 by 3, yeah? Okay.
Ma'am, yes, ma'am.
Okay. Fine. The product of two numbers is minus 8. So one number into other number. One number
I got 2 by minus 3.
2 by minus 3. Okay, let's check. One number into other number is equal to minus 8. The product of two numbers is minus 8. So one number into another number is equal to minus 8. One of them is minus 12. So minus 12 into other number is equal to minus 8. So the other number is equal to minus 8 by, see this minus 12 when it comes to the other side, it will not become plus 12. It's in multiplication. As it is, it will come for division. As it is. You cannot do two things at a time. You cannot bring it for division and change the sign. Either when it goes to the other sign, plus becomes minus. Or if multiplication comes down for division, it will come as it is. Minus 12 will come to the other side for division as minus 12 itself. You should not change the sign. If you have changed the sign, you're wrong. It's in multiplication. So it comes to the other side. For division. Okay. All right. So the other number is? The other number is? Minus cancels 2 by 3. 1 minute. I've got a text from Anintika. It seems she's waiting and I have to let her in. The lobby is open, no? I don't. See, she's not. Yeah, Anintika, you're in, right?
Yes.
Yeah. No. The lobby is always enabled. I hope you understand that the lobby is always enabled. I don't admit children one by one. So nobody's, when I start the meeting, once I start the meeting, you just come into the meeting. Like you from the lobby, you just enter the meeting. I don't admit anybody. So yeah, maybe you had some other trouble. So I did not admit you now, actually. You just got into the meeting because the lobby is always open. All right, no issues. So I think I should tell you that we're just discussing the answers to the questions I had posted on Intika. And we are now in the
Can you please tell the answers of the previous questions
Sure.
so that I can check if it's correct?
Yeah. I'll at the end of the class. Okay, let me tell you now. You read out your answers, Anintika, for the first one.
Okay, the first one is 7 upon 10.
First one, additive inverse of 7 by minus 10. No, Anintika, actually it doesn't work this way because, the others have to wait. Anyways, the recording will be there. I'll share the recording with you. So the first few minutes of the recording, you will get the solutions with the working. All right, Anintika?
Okay.
Yeah. So children, I was telling you that minus 12 comes to the other side for division as minus 12. So minus cancels and the other number is 2 by 3. The other number is 2 by 3. Somebody got 2 by minus 3, you said, right?
I actually forgot the minus on 2, so I couldn't cancel.
Okay. Yeah, I'll wait for a minute just in case you want to take down the answers, children. The answer, you can take it down.
These are the questions that you had given as homework, not the one you said recently before the class.
No. We are discussing the answers to the, the picture which I sent today, not the earlier one. No.
Okay.
Yeah. Oh, so you were sharing the answer to that one, is it?
Yeah.
Okay. No, there's another girl in the class, so we'll discuss the answers to that assignment in the next class. I'll just share the same with her and give her time to finish. So next class, we'll definitely share the answers to the assignment I posted earlier. Yeah, the other number is 2 by 3 children. Fine. Next, evaluate. Anantika, what's your answer for question number 7, first subdivision? 5 ones are 5 twos are correct, children. Minus 6 by 7, right?
Yes, ma'am.
Yes. Why is it written question 8 first part?
Yes, ma'am. Minus 6 by 7.
Yeah, that's why I got confused. And I told the different
Anantika.
answer.
Oh, sorry, Anantika. No. When I started the meeting, I told them, don't ignore the question above. We are discussing the answers to the questions I had posted today on WhatsApp.
Yeah,
All right?
minus
Yeah.
Yeah.
Sorry. Yeah. I did make that announcement when I started the class. Since you joined in the middle, you missed that one. All right, children. Yes. Now, this means the power minus 1 means the reciprocal. That's how we write symbolically. In words, we say the reciprocal of whatever, 3 by 5. But if you want to write that symbolically, we write 3 by 5 to the power minus 1. Indicating, write the negative, write the reciprocal of whatever is in the bracket. The power minus 1 indicates, write the reciprocal of the base. Let me tell you that again. When the power is minus 1, it indicates that we have to write the reciprocal of the base. That's a symbolic way of writing the reciprocal of a number. See, if I have to explain this in words, it is write the reciprocal of minus 5 by 8. Write the reciprocal of minus 5 by 8. This is in words. Write the reciprocal of minus 5 by 8 in words. If I have to write the same thing symbolically, then I say, what is the value of minus 5 by 8 to the power minus 1? When I raise it to the power minus 1, it means write the reciprocal of the base. This is the base. This is the power. Minus 5 by 8 is the base. And minus 1 is the power. When the power is minus 1, we need to write the reciprocal of the base. So what's the reciprocal of the base? Minus 8 by 5. This is the answer. All right, children?
Yes, ma'am.
Very good.
Okay, ma'am.
So when the power is minus 1, it means we have to write the reciprocal of the base. The base is minus 5 by 8. The reciprocal of minus 5 by 8 is minus 8 by 5. That's it. Okay, next. Again, write the reciprocal of minus 6. That's what this question means. Write the reciprocal of minus 6. The base is minus 6. The power is minus 1. When the power is minus 1, it means write the reciprocal of the base.
Minus 1 upon 6.
Minus 1 by 6.
Minus 1 by 6.
Yeah, because the base is minus 6, which means minus 6 by 1. The base is minus 6, which is minus 6 by 1. So the reciprocal of this one will be minus 1 by 6. Because the base is minus 6 by 1. So its reciprocal will be minus 1 by 6. Very good. Minus 1 by 6. Very good, children. Yes, Anantika, the first property. Name the property.
First property is commutative property.
For 1 mark, you will only get half for that. Leave the heading, okay? The heading is given name the property of multiplication. Supposing the heading is just name the property. The heading is just name the property. Then what would you say?
Commutative property of rational numbers under multiplication.
Correct. Commutative property of multiplications. Sorry, commutative property of multiplication of rational numbers. Commutative property of multiplication. We must specify the operation there. Commutative property of multiplication of rational numbers. Okay. Second one. Aishwarya Shri. Second one.
Identity property.
Correct. Multiplicative identity. Multiplicative identity. Very good. Correct, children, because minus 8 by 15
Yes.
into 1 is minus 8 by 15. Multiplicative identity. Very good. Next one. Third one. Shreya, third one. Aishwarya.
Sorry, ma'am. Sorry,
Yeah,
ma'am. I just had a block. Associative property of multiplication and rational numbers.
Very good. Yes. Associative property of multiplication of rational numbers. Very good. Aishwarya, next one.
Ma'am, additive identity.
Where is addition there, Aishwarya? It's minus 2 by 3 into 0 is 0. It's multiplication.
Oh,
No, there is no
multiplicative.
addition there.
Yes, ma'am.
Okay, maybe I've not stated a property like that in the class, so you can just say the property of 0. The property of 0 for multiplication of rational numbers. I'll write it here. The property of 0, because any rational number into 0 is 0. The property of 0 for multiplication of rational numbers. Next one.
Ma'am, it's
Who's that?
distributive.
Sai Smriti. Sai Smriti.
Yes, ma'am. Distributive property of multiplication under addition of rational numbers.
Very good. Distributive property of multiplication over addition. Distributive property of multiplication.
Ma'am, I'm having a doubt, ma'am.
Yes.
Should we also mention rational numbers in distributive property?
Yeah, you can mention. You can mention. It's okay if you don't mention also. It's okay if you don't mention, but you should mention these things should be there. Distributive property of multiplication over addition. These must be there. For rational numbers, you can include.
Yes, ma'am.
Yeah. Very good. And now the ninth one we haven't still discussed, so we'll do it now. Meaning we haven't taken up that concept in the class, how to insert rational numbers. I don't remember doing them. So
Ma'am,
let's
you
learn
have
that
taught
now.
this. You told to take the LCM of the denominator and make it equal.
Oh, okay, fine.
Yes, ma'am.
Okay. Now I'll teach you another method by using the concept of mean. Okay. So find two rational numbers lying between. The question is find two rational numbers lying between minus 1 by 3 and 1 by 2. Minus 1 by 3 and 1 by 2. Okay. So this method, it's very tedious, it's cumbersome, but Sometimes when they specify that you have to find the rational numbers using this method, then you have to. Using the concept of mean, M-E-A-N, mean. If the question specifies that you have to insert the rational numbers between these two rationals using the concept of mean, then you have to do this method. You have to use this method. It is tedious, but then you have to do it. So let's learn that method now. Here it is not specified. Here it's not specified though, but let's learn this method now through this question. So we have -1/3 and 1/2. Okay, so we have to insert two rational numbers. A rational number, we begin like this, a rational number lying between -1/3 and 1/2 is half of their sum. Half of their sum. See now, you can just understand why this will work. Supposing you have two numbers, 4 and 6. Add and divide by 2. That number will definitely between 4 and 6. I'll repeat. Consider two numbers, 4 and 6. Find their sum and divide by 2. The result will be between 4 and 6. The result will be between 4 and 6. So you can see it is 10/2, 5. And this number 5 is between 4 and 6. Say 11 and 13. Okay, 11 and 12. 11 and 12. 11 plus 12 by 2. We take two numbers, 11 and 12. We add and divide by 2. So this will be what? 23/2. And what is 23/2? It's 11.5. And clearly 11.5 lies between 11 and 12.
Yes, ma'am.
When you take two numbers, find their sum and divide by 2. Find their sum and divide by 2. That resultant number will lie between the two numbers. Will lie between the two numbers. Now, for example, 100 and 200. 100 plus 200 by 2. 300 by 2. 150. So you can see that when we take these two numbers, 100 and 200, find their sum and divide by 2. The resultant number is 150, which clearly lies between 100 and 200. So that is what we're using here. A rational number lying between -1/3 and 1/2 is half of their sum. See, by 2, 1/2 meaning dividing by 2. Half of dividing by 2 is 1 into 1/2. Okay. Let me clarify that also. Now see your children. When I write 10 divided by 2, it means 10 into 1/2, right?
Yes.
So
Yeah,
when you
yes,
write,
ma'am.
when you multiply by half, that means you're dividing by 2. When you multiply by half, if you're multiplying by 2, that means you're multiplying by 2. But if you multiply by 1/2, that means you're dividing by half. You're dividing, sorry. You're dividing by 2. When you multiply by half, it means you are dividing by 2. Now 15 divided by 3 means 15 multiplied by 1/3. It's the same. Dividing by 3 is the same as multiplying by 1/3. Similarly, 15 divided by 2. Dividing 15 by 2 is the same as multiplying 15 by 1/2. So that's what we're doing here. Into 1/2 meaning dividing by 2. Add the numbers and divide by 2, I said. Divide by 2 is nothing but multiplying by 1/2. That's what you see here. So half of, find the LCM here, children. 3 to the 6. So it will be into 2. Yeah, into 2, into 2, into 3, into 3. So it will be -2 plus 3. So half of minus, what is this? 3 minus 2, 1. 1/6. So that is equal to
1/6, ma'am.
Yeah, 1/6, which is 1/12. Multiply the numerators. 1 into 1 is 1. Multiply the denominators. 6 to the 12. 1/12. So 1/12 is a rational number. It's not the only rational number. There are infinitely many rationals lying between two rationals. Between two rationals, there are infinitely many rationals. This is one of the rationals lying between minus 1 by 3 and 1 by 2. So now what does this mean? I'll show you the slide again so that you can write. So this means minus 1 by 3, 1 by 2, 1 by 12. Minus 1 by 3 is less than 1 by 12, 1 by 2. Or okay, this might be complicated for you. So now that means what? This is between 1 by 12 is between minus 1 by 3 and 1 by 2. Minus 1 by 3, 1 by 2. Between that is 1 by 12. Is that fine, children?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Okay, ma'am.
Now we'll find a rational number. You can either find the next rational number between these two. Between these two, that is minus 1 by 3, 1 by 12, 1 by 2. Now you can find another rational number between these two, or you can find it between these two. See, when you find a rational number between these two, that's also between minus 1 by 3 and 1 by 2. And when you find a rational number between 1 by 12 and 1 by 2, when you find it here, that number is also between minus 1 by 3 and 1 by 2. Okay.
Yes, ma'am.
Yeah. See, minus 1 by 3, 1 by 2 are the given numbers. We inserted one number, one rational number between these two. Now to find the next one, you can use the same technique to find a number between these two. Okay. So the rational number lying between these two will also lie between minus 1 by 3 and 1 by 2. Or you can find a number between these two, which will also lie between minus 1 by 3 and 1 by 2. So you can go on like this. Then you can find a number between these two. You get a number, then you can find a number between these two. You can go on like that. Now we just need one more number. We just need one more number because two numbers we have to insert. So we just need to find one more number. So a rational number between minus 1 by 3 and 1 by 12 is half of their sum. Half of LCM is 12. So into 4 into 4. So it will be minus 4. Here it is into 1. So minus 4 plus 1, which is half of minus 3 by 12. Now simplify. 3 ones are 3 fours are. So it is minus 1 by 8. Minus 1 by 8. So now these are the two rationals between minus 1 by 3 and 1 by 2. See, you can present it like this. Therefore, minus 1 by 3 less than. Now this is here, right? This is here, minus 1 by 8. So less than minus 1 by 8. Then we have 1 by 12 is less than 1 by 12 is less than 1 by 2. 1 by 2. In the ascending order. This is the ascending order. One by 8 is between 1 by 3 and 1 by 2. And 1 by 12 is between minus 1 by 3 and 1 by 2. Minus 1 by 8 is between minus 1 by 3 and 1 by 12. Right on, children? We'll try another question like this. That should be, with that, it should become clear.
Yes, ma'am.
Yeah. The question is find two rational numbers lying between -1/3 and 1/2. Can I show the next slide?
Yes, ma'am.
Yes, ma'am.
Yeah. All right. Yeah. Done, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All right. All right, children. Now we'll also do it using that the first method. Let's call it alternate solution. You need not get the same answer because there are infinitely many rational numbers lying between two rationals. So in this alternate solution, it is not necessary that you should get the same two numbers. Okay. Now -1/3 and 1/2. So -1/3, the LCM is 6. So this will be -1/3 into like this, right? -2/6. And this is 1/2 into 3/3. So that's 3/6. So two rational numbers lying between -1/3 and 1/2 are you can see the numerator. From -2, you can write till 3. So -2, -1, 0, 1, 2. So -2/6, 3/6. So you have -1/6, 0/6, 1/6, 2/6. There are many more numbers, but you can clearly find these. Yes or no, children?
Yes.
Yeah,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yeah, I'll just write it once again. You can just have a look at the screen. So I just, since the denominators are the same, we are only concerned with the numerators. So -2 on the left side, 3 on the right side. Now between -2 and 3, what are the integers we have? We have -1, we have 0, we have 1 and 2. Take everything with the denominator 6 because it's -2/6 and 3/6, right? So -1/6, 0/6, 1/6, 2/6. So you can just write any two. So you can write probably -1/6 and 0, or -1/6 and 1/6. Whatever, your choice. If you're writing 2/6, you should simplify that to 1/3. Okay, so R -1/6 and 1/6. Write any two. So this method is simpler, and simpler meaning less time consuming. The other method, which is the using the concept of mean, takes a little more time. Done, children?
Yes, ma'am.
Okay.
Yes, ma'am.
No, you're all writing it down, right? Or just listening to
Yes,
me?
ma'am.
No,
You're
we're
all
writing
making
it.
a note.
We're writing it down.
Yeah, yeah, yeah. Yes, yes, children. Very good, very good. We'll come to this one in the next class. Let me just, yeah. Yeah, quickly. Shreya, first one.
Just a second. Minus 17 by 4.
I'll give you another chance. I'll give you another chance, Shreya. You can correct yourself if you think you're wrong. Sai Smriti. Sai Smriti. Aishwarya Shri. Aishwarya.
Minus 12 by 5.
Anantika.
0.
Yeah, 0. The product is 0. Minus 4 by 7. We all know that. Fine. You probably overlooked the question. So you all know that. Into 0 is 0. Yes, Shreya, try the next one. Sai Smriti.
Yes, ma'am. Minus 12 by 5.
Minus 12 by
5.
very good. Aishwarya, next one.
Yes, ma'am. Minus 8 by 13 plus 0 is equal to minus 8 by 13.
Very good, very good. Yes. Aishwarya Shri, next one.
Minus 7 by 15 equal to 0.
No, what should be taken in the blank? Minus 7 by 15 minus what is 0?
15.
No.
Ma'am, can you hear me?
Minus
Yes.
7 by 15.
Aishwarya Shri, repeat your answer. Yeah,
Minus
anybody?
7
Minus 7 by
by
15, no?
Can I tell?
0, ma'am.
Shreya, is it?
Yes, ma'am. 0.
Ma'am, can I tell?
Yes, Sai Smriti.
Minus 7 by 15.
Yes.
Anantika.
1 second.
Ma'am, I got it.
Yeah, tell me.
Plus 7 by 15, ma'am.
Shreya.
Yes, ma'am. Plus 7 by 15.
Ma'am, it would actually, if we say minus 7 by 15 minus, and then if we put in brackets minus 7 by 15, it should be the same.
No, what should be taken in the blank?
Then plus by 7. Then plus by 7 upon 15.
Okay, so you want to write this in the blank, right? Plus 7 by 15, correct?
Yes, ma'am.
No.
Sai Smriti was right. She said minus 7 by 15.
Yeah, but in brackets.
Yeah, see, whenever we have two signs, you have to, so you should just told me that in the bracket, minus 7 by 15. It's a blank, right? So you're free to write whatever you want there. There is nothing like you should not use a bracket in the blank. It's a blank. There is no restriction. You can use a bracket there. So even Sai Smriti, you said the same thing. In brackets, minus 7 by 15. Because minus into minus plus. So it will be minus 7 by 15 plus 7 by 15, 0. Minus 7 by 15 is the correct answer. Because This is minus 7 by 15. Minus 7 by 15. Minus into minus plus 7 by 15. Minus 7 by 15 plus 7 by 15 is 0. Next one. Anybody can answer that?
Ma'am, minus 11 by 18 minus 0 is equal to minus 11
Yeah.
by 18.
0.
0. Very good.
Same.
Shreya, repeat all the answers from the beginning.
Pardon,
Yeah,
ma'am? I
others,
can't.
take down all of you. It might look simple, but I want you to make a note of this. Yeah, start writing. Yes, Shreya, the first one.
Ma'am, it is 0. The first one 0.
Okay, correct.
The
Second
second one is minus. The second one is minus 12 by 5.
Correct. Aishwarya Shri, next one.
0, ma'am.
Very good. Next one, Aishwarya Shri.
Minus 7 by 15.
In bracket, right?
In bracket, ma'am.
Very good. Anantika, last one.
0.
0. Very good. Children, kindly take a make a note of all this. Take it down.
Done, ma'am.
Very good.
1 minute, ma'am.
Yeah. Fine.
Done, ma'am.
Okay. Fine. Yeah. One minute. I just want to. Yeah, we'll do these number line questions and then we'll represent. Yes, we'll do this. Answer this question. Okay, let's start from the beginning. Multiple choice questions. Anybody can try the first one?
1 second.
Yeah.
Yes, ma'am.
What's up? Girls, are you all there?
Yeah, ma'am.
Yes, ma'am.
Yes,
Yeah,
ma'am.
what's
Yes,
up?
ma'am.
What's happening? Does it take this long? Okay, fine.
Ma'am,
Another minute.
if
Okay, cool. Fine, 1 more minute, I'll wait.
Ma'am, I think I got the answer.
Yeah. Tell us.
Ma'am, I'm getting it as C.
C. Okay. C is the only one, is it? Okay. Aishwarya says C.
ma'am,
Aishwarya A. Okay. Yeah.
ma'am, it's minus 21 by 60, ma'am.
Shriyan. Okay. Okay.
Ma'am, I got minus 16 by 20.
And C.
Okay. Aishwarya, Shri, and Anantika have to share.
Both A and C, ma'am.
Both A and
C.
C. Okay. Aishwarya,
I'm
Shri says
getting
both.
C.
Anantika is getting C, is it?
Yeah.
Okay. Fine. Now, minus 8, don't change your answers. So listen to me, minus 8 by 20, minus 21 by 60, minus 16 by 20, minus 77 by 140. Now the thing is, we'll have to have, there are 5 fractions, including minus 3 by 4, including minus 3 by 4. There are 5 fractions. Now the thing is, to compare fractions, you need to have them with the same denominator. That's the fundamental. How do you go about answering this question? How can you compare fractions? You cannot compare unlike fractions. You cannot, meaning it's difficult to compare unlike fractions. You have to make them like fractions. And what are like fractions? Fractions with the same denominator are called like fractions. And it's easy to compare like fractions. So that's the first thing you'll have to do. You'll have to bring all the 5 fractions. There are 4 answers and one with one fraction in the question. You need to bring, okay, I'll say rational numbers. Okay, so not fractions, okay, rational numbers. You need to bring all these rational numbers to the same denominator. So now when you look at this, 4, 20, 60, 20, 140. So what we can do, you can have the 20 as it is. We'll try to bring this to 20. See here, so into 5 by 5. So this will be what? Minus 15 by 20. Now this one will try to reduce, okay? So 3 2s are 6, 0, 3 7s are minus 7 by 20. And this also will reduce in the tables of 7, and that will be minus 11 by 20. So like this, easily we've brought everything to the, we've got all the rational numbers to the denominator 20. Now let's put them on the number line. Okay, now let's put, it's easy. It's now it's very clear, but still. See, you need to first observe all the fractions. Denominator 4, denominator 20, 60, 20, 140. So 4, you can bring it to 20. So that means if you bring denominator 4 to 20, that means now we have 3 rational numbers with denominator 20. So minus 8 by 20, though it is possible to simplify, don't simplify. See, minus 8 by 20, you can simplify it further, but don't simplify. Because you want to have all the rational numbers with denominator 20 so that it becomes easy to compare. So bring minus 3 by 4 to denominator 20, minus 15 by 20. Minus 8 by 20, do not disturb. Then minus 21 by 60 can be reduced to minus 7 by 20, so denominator 20. And then minus 16 by 20 as it is. You can simplify using the tables of 4, but don't disturb the denominator 20. And the last one, minus 77 by 140, reduce it and bring it to the denominator 20. Now, look at the numerators, minus 15, minus 8, minus 7, minus 16. So let's start writing minus 7, okay, minus 7, minus 8, minus 11, no, by 20, of course, okay, by 20 is there, by 20 is there. So minus 7, minus 8, minus 11, minus 15, and minus, what's the other one?
60.
Where is it? I can't see it. Oh, yeah, here, minus 16. Yeah, minus 16. Minus 16. See, all by 20, children, all by 20, everything by 20. So this is how they look on the number line. Okay, so minus 7 by 20, minus 8 by 20, minus 7. So now the question is, what is minus 3 by 4? Minus 15 by 20. Minus 3 by 4 is minus 15 by 20. This is minus 3 by 4. Now the question is, which of the following rational numbers is less than minus 3 by 4? Less than minus 3 by 4 on the number line. So less than minus 3 by 4 is minus 16 by 20. Yes. So Aishwarya was right. Aishwarya Shri gave 2 answers, so you're wrong. Sai Smriti was right. And Anantika was also right. Okay. Now is it understood, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Kindly make a note of it.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So this is the correct answer.
Mom, but I haven't done it in the same method though.
Okay, I'll let me ask you. Just make a note of this. Let me ask you how you did it. Did you find their values using a calculator?
No, ma'am.
I made the LCM. I found the LCM of 4 and then the denominator of the first and the second and third and fourth. And then I found out which is less and I got it as C.
Come again?
So basically it was minus 3 by 4. So I took the first one minus 8 by 20. I found the LCM of 4 and 20 and multiplied the numerator. And then I found out if in both of these fractions, which one is less, is it greater or less?
Okay, so you've compared each one of the option
Yes,
given with minus 3 by 4. Okay, fine, good.
Yes.
All right.
Ma'am, I have taken note.
Very good. So rational numbers can be compared only if they have the same denominator. Rational numbers with different denominators cannot be compared. It's difficult to say which is, small or big. So rational numbers must have the same denominator in order to compare them. And that's exactly what we're doing here. Including the rational number given in the question, we have 5. So we bring them to a common denominator, 20 in this case. So once the rational numbers are with the same denominator 20, it's easy to compare them. So less than minus 3 by 4. As you go towards the left, when you move towards the left, the numbers keep decreasing in value. When you move, okay, so when you move like this on the number line, numbers keep decreasing in value. This way, numbers keep increasing in value. When you walk like this, when you walk towards the right on the number line, the values keep increasing. Left decreases. So which of the following rational number is less than minus 3 by 4? So less than 15 by minus 15 by 20. So to the left, minus 16 by 20. Okay, next one, children.
Option A, ma'am.
B, ma'am.
Option A. Anantika says B.
Okay,
Shreya, B, ma'am.
okay,
Ma'am, Sai Smriti A, ma'am.
okay.
Ma'am, Aishwarya B.
Mm-hmm.
Aishwarya C.
Okay. Which of the following statements is true for a rational number minus 2 by 3? It lies to the right side of, which is true, okay? So it lies to the right side of 0 on the number line. Sai Smriti, this is 0 minus 2 by 3.
I'm sorry,
Lies-
ma'am. Actually, it is B, ma'am. I haven't read the question properly.
Yeah, minus 2 by 3 will lie to the left of 0. Minus 2 by 3, all negative numbers to the left of 0. So it lies to the right of 0. This number does not lie to the right of 0. So the first one is wrong. Okay. It lies to the left of 0 on the number line. Yes, it lies to the left of 0. This is correct. It is not possible to represent on the number line. No, this is wrong. And none of the above. Oh, okay. Yeah, B is right. Okay, let me ask Aishwarya Shri, why you felt minus 2 by 3 cannot be represented on the number line? Okay, see, every rational number has a unique position on the number line. Every rational number has its own position on the number line. There are infinitely many rational numbers, and every rational number has its unique place or unique position on the number line. Okay, so to represent minus 2 by 3 on the number line, the correct answer is B. The correct answer is B. Minus 2 by 3 lies to the left of 0. If it was positive, to the right of 0. All positive integers to the right of 0. Negative integers to the left of 0. We all know that, fine. So now how do you represent minus 2 by 3? It's going to be like this. So 0 minus 0 means 0 by 3, minus 1 by 3, minus 2 by 3, minus 3 by 3. This minus 3 by 3 is minus 1. Minus 1. This minus 3 by 3 is minus 1. 0 by 3 is 0. So here is minus 2 by 3. Here is minus 2 by 3. All right. Next one, children. Find the value of A.
C, ma'am.
Anantika C.
Shreya, C, ma'am.
Ma'am, C, ma'am.
Aishwarya C.
Okay. Anybody with a different answer? Okay, so it's actually the rational number that lies between or exactly in the middle. Okay, so A is a point. A represents the point on the number line between -2/7 and -6/7. So how do you find that? -2/7.
The series are of this even numbers, so -4/7 out of the options.
Okay.
Ma'am, but I still have a question.
It is.
Ma'am, I still do have a question.
Yeah, 1 minute. -2/7, -4/7, -6/7, -8/7. Yeah. What's your question?
Ma'am, the question is multiple choice question, so it can be more than one, right?
You're asking me the meaning of the heading. Is it multiple choice questions?
No, if it's more than one, I got the answer -4/7. But is it possible to write? Is it possible that there can be 3 answers because it's multiple choice?
No, it depends on the question. See here, which if it is which one of the following, then it is only one. Which of the following? So you can have more than one answer. It depends on yes, okay, let me answer your
So it
question like
can
this.
be
It is possible.
-3/7, -5/7, or -4/7.
That's what I was telling you, that it is exactly between, in the middle of -2/7 and -6/7. You can see the spacing. And that's how
Yeah.
we have to understand this question.
Yes, I got that, but I just wanted to still clarify.
No, in this case, it's only one answer, -4/7. But well, in multiple choice questions, you can have, now in this case, in this one, you can have more than one option. If it was there, you can have more than one statement true. But not here, because every rational number has a unique position on the number line. A cannot represent more than one rational number. The point A,
Yes.
the point A cannot represent more than one rational number. So here you cannot have multiple answers.
Yes, ma'am,
But
understood.
yeah, in questions like this, you can have, like, this can be true for this one, this can be true. Yeah. So here the answer is -4/7. -2/7, -4/7, -6/7, -8/7, -10/7, and so on. -4/7. From the number line, find the reciprocal of P. So you can see P here.
8/4, ma'am. Option C.
Option D.
Aishwarya's tree.
Option C.
Ma'am,
Right.
another option D.
8/2.
Oh, okay. C, yeah. Option C.
Option C, 8/4.
C, ma'am.
Ma'am, C.
Ma'am, C.
How many of you say C? Anantika, then?
Who's Aishwarya?
Shreya.
Ma'am, Aishwarya. Who's Aishwarya's tree?
You also say C, is it?
Yes, miss.
Okay. And anybody else with C?
Sai Smriti, ma'am.
Okay. Who says D?
Ma'am, it's me, Anantika, and I'm confused between C or D. I think it could be D.
Ma'am, yeah, yes, ma'am, because if but
Ma'am, I changed my answer, Anantika, D.
Okay. Yeah, D is the correct answer. Once again.
so if we cancel the reciprocal, we can still get the same answer.
It's the same. They are not two different numbers. See, now if you 10/20 is the same as 1/2. When you reduce it, you get 1/2. It's the same. Now, what is this? 4/8. 4/8 is nothing but 1/2. When you reduce it, it's nothing but 1/2. It's nothing but, so you can treat it as 4 by 8. You can also treat it as 1 by 2. Both are correct. 4 by 8 can be treated as 4 by 8 or 1 by 2. Both are the same. They're not different. So the reciprocal of 4 by 8 is 8 by 4. If you treat it as 4 by 8, it is 8 by 4. If you treat it as 1 by 2, then the reciprocal is 2. Both are correct. So both B and C. Both are the same. What do you think 8 by 4 is? 2 only. What do you think 2 is? 8 by 4. So it's the same. It's the same. P is equal to 4 by 8. Reciprocal is 8 by 4. When you simplify this, this is 1 by 2. So its reciprocal is 2. So it's 2 and 8 by 4. Both are correct. So both B and C. Both B and C. Both B and C. Yes or no, children?
Yeah, ma'am.
Yes, ma'am.
Yeah. Yeah, take a screenshot and write this down on your book later. Mark the correct answer. Take a picture. Please complete this. Leave some place for writing this.
Yes.
Only then you will realize that something has to be completed in the book. Take a picture and now don't continue. Leave some space for this and continue writing. Done, children? Taken a picture?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Yes. Write the rational number for each point labeled with a letter. Yeah, this one, children. What is A?
Can I tell, ma'am?
Yeah.
1 by 5.
1 upon 5.
1
1
by
by
5.
5. This one?
4 by 5.
4 by
4 by
5.
5. This one?
1.
5
5
by
by
This is a question mark, children.
5 by
In case
5
it's not
or
clear,
1.
these
1.
are question marks, children. These are question marks. Just in case it's not clear, they are question marks. Yeah. So
Ma'am,
this is 1 by 5, 4 by 5, 5 by 5, which is 1.
which is equal to 1.
Yeah,
by
correct then. 8 by 5,
8 by
8 by
5.
8 by 5,
9 by
9 by 5.
9
by
by
5.
5. Very good. Very good. Here,
minus 11 by 6.
7 by
Minus
so
11
let's
by
come from
6.
0 by 6 minus 1 by 6. What is this? Minus.
minus 2
2
by
6.
6.
2 by
And here
6.
G,
Minus 5
Minus
by
5
6.
by 6.
Minus 5 by 6.
H,
Minus 7 by 6.
Minus
Minus
7 by
7 by 6. And the next
Minus
one is
8 by
minus
6.
8 by 6.
Minus 11 by 6.
Minus 11 by 6.
very good. Very good. Very good. Very good. This is how we represent rational numbers on the number line.
Yes, ma'am.
This is how you represent rational numbers on the number line. Supposing you're asked to represent minus 9 by 6. Represent minus 9 by 6 on the number line. This is what you should do. Draw a number line. Start off with 0 by 6, minus 1 by 6, minus 2 by 6, minus 3 by 6, and move on to get till you get minus 9 by 6, and then show one number, one rational number extra, minus 10 by 6. Or you can go up to minus 12 by 6. This is minus 1, minus 6 by 6 is 1, minus 12 by 6 is minus 2, and 0 by 6 is 0. So 0, minus 1, minus 2. If you're asked to represent 11 by 5 on the number line, 11 by 5 on the number line. So 11 by 5, the denominator is 5. So we start with 0 by 5. 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. 5 by 5 is 1. So 0, 1. Then 6 by 5, 7 by 5, 8 by 5, 9 by 5, 10 by 5, 11 by 5. This is the position of 11 by 5. See the spacing just uniform. The spacing should be uniform. It can be anything. It can be half a centimeter. The spacing can be half a centimeter, or you can make 3 millimeter spacing, whatever. But the spacing should be uniform. That's all it is. You can take 1 centimeter spacing. Spacing between two consecutive rational numbers must be the same. The spacing can be anything, but it should be uniform. That's all it is. The spacing can be half a centimeter or half a centimeter, meaning 5 millimeters or 4 millimeters, 3 millimeters, or you can take 1 centimeter. But it should be uniform. It should be uniform throughout. Yes, children. Aishwarya Shri, how will you represent these numbers on the number line? Are you there, Aishwarya Shri? Yeah. I'll mark 0 here.
Yes.
Then left or right? Where should I start marking? To the left or right of 0?
Left.
Left. What will be the first rational number here?
Minus 1 by 11.
Yeah, 0 means 0 by 11. Then minus 1 by 11. Next.
Minus 2 by 11.
Okay.
Minus 3 by 11.
Okay.
Minus 4 by 11.
Faster, faster.
Minus 5 by 11. Minus 6 by 11. Minus 7 by 11. Minus 8 by 11. Minus 9 by 11. Minus 10 by 11. Minus 11 by 11.
And what is minus 11 by 11? What's the value of minus 11 by 11?
1. Minus 1.
Minus 1. Minus 11 by 11 is minus 1. And the 0 by 11 is 0.
0.
Yeah. So you can just mark simply, you can just mark minus 12 by 11 if you want. That's enough. This is how you represent rational numbers on the number line.
Yes,
so we have represented minus 2 by 11. So you can mark this point A. Then minus 5 by 11 B. Minus 9 by 11 C. So point A represents minus 2 by 11 on the number line. Point B or simply B. B represents minus 5 by 11 on the number line and C represents minus 9 by 11 on the number line. Yeah, take a picture, children. Please complete this at home later.
Done, ma'am.
Yeah.
Done, ma'am.
Yeah. So children, I think you can help yourself with this homework on different number lines, separate number lines, okay?
Yes, miss.
So how do we do 17 by 5? How do we do 17 by 5? So we start with 0 by 5. Since it's positive, we'll take the rational numbers to the right of 0. It's positive. If it's negative, we'll have to mark on the left of 0. This is 17 by 5 positive. So to the right of 0. So since the denominator is 5, in 17 by 5, the denominator is 5. So we start with 0 by 5. 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. This is 1. 5 by 5 is 1. 0 by 5 is 0. Then continue. 6 by 5, 7 by 5, 8 by 5, 9 by 5, 10 by 5. 10 by 5 is 2. Continue. 11 by 5, 12 by 5, 13 by 5, 14 by 5, 15 by 5, which is 3. This is 3. 16 by 5, 17 by 5. This is what we had to mark. You can mark this point P. 18 by 5, 19 by 5, 20 by 5, which is 4. So P represents 17 by 5 on the number line. Can you take a screenshot? Complete this later. Finish all the others, children.
Ma'am, now or later?
Later. Leave some place. That's what I would suggest.
Okay, ma'am.
Yeah. write down the question at least, children, because then, yeah, I think the earlier one also, just take down the, what was that? No, those were multiple choice questions. It will take some time to write. This one, just make a note of the question at least and leave some space for the answer. All right, children. Yeah. Let me just, we'll do this one. Insert, yeah, 10 rational numbers. We'll do this. Find 10 rational numbers between 1/3 and 1/2. Find 10 rational numbers between 1/3 and 1/2. Now here you cannot use the mean method because that will take a long time. So we'll use that other method where we, bring the two rational numbers to the same denominator.
Ma'am, we should take LCM, ma'am.
Correct. Correct. LCM of 3 and 2 or 2 and 3 is 6. Correct. So 1/3
Yeah.
into 2/2. 2/6.
2/6 and 3/6.
1/2 into 3/3. So this will be 3/6. But between 2/6 and 3/6 in the numerator, there is no space. 2, 3. 3 follows 2. 2, 3. So actually you can insert. I'll tell you that also later. But now 2/6, 3/6. So there is no gap between the numerators. There is no space between the numerators. 2, 3. There is no space. So the next thing is you have brought the two rational numbers to the same denominator, but the numerators, they don't have space. So you need to, extend that space, increase the space between the numerators. So how do you do that?
By finding the highest common.
No. Just continue like 1 minute, 1 minute.
Ma'am, should you multiply it with a bigger number?
That's it. Yes, just multiply with a bigger number. You can say into 10/10 or 100. Anything. Or you can do into 11/11. Okay, see here. Normally what we say is when you want 10, take one more than that. So 11/11. If you want 10, just take one more than that into 11/11. So 22/66. And here into 11/11 will be 33/66. See, if you want 15, then take one more than that. In 16/16, multiply by 16/16. Am I clear, children?
Yeah,
Yes,
ma'am.
ma'am.
Okay. So now you can say 10 rational numbers. 10 rational numbers between 1/3 and 1/2 are, okay, so 22 to 33. Between, okay, so you should not write 22. 23/66, 24/66, 25/66, 26/66. So like this, it goes on till 32/66. 32/66. And if you count, there'll be 10.
Yeah.
Count, there'll be 12. 10. So the thing is, first bring them to the same denominator using the concept of LCM. After that, though the denominators are the same, you don't have space between the numbers and the numerator. 2, 3. What can you insert between 2 and 3? So next what you have to do is, how many numbers you want to insert? 10. Take one more than that, 11. Multiply both the fractions or both the rational numbers by 11/11. So now the space in the numerator is increased. It's 22/66 and 33/66. The denominators are still the same. Now the space The gap between the numbers in the numerator has increased 22, 33. Now you can insert. So after 22 is 23, 24, 25, 26 goes on till 32 by 66. So you should put an equal to sign everywhere, children. See, 1 by 2, 1 by 3 into 2 by 2 is equal to 2 by 6. Into 11 by 11 is equal to everywhere. It's all the same. All these are the same. 1 by 3, 2 by 6, 22 by 66, all are the same.
Understood, ma'am.
Yes, ma'am.
Yeah.
And do we have to complete the other sub questions in this question?
Correct. I'll do the fifth one now. The rest you can try as homework. I'm going to do the fifth one now. Or we can do everything. If you want me to work everything, we can do everything now. Taken down this, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. So now 5. LCM of 5 and 4 is 20. Then minus 6 by 5 into what, children? How do you bring it to the denominator 20?
4.
Yeah.
4.
Minus 24 by 20. Next, 7 by 4 into
5 by 5.
5 by
5 by
5 by 5.
Yeah, 35 by 20. Now you need to insert 10 numbers. Do you think you have space in the numerator? You have lot of space because minus 24 and 35. My God, so many numbers. Minus 23, minus 22, minus 21, minus 20, minus 19, minus 18, minus 17, minus 16, minus 15, minus 14. Oh, so many numbers. Then 0, 1, 2, 3, 4, 5, 6, till 35. So many numbers. We have much, much more than 10. So now this is enough. You don't have to further increase the space between the numbers in the numerator because as it is, there is more than sufficient space. So 10 rational numbers between minus 6 by 5 and 7 by 4 are, tell me, children. See here, minus 24 here. Okay, 0 and 35. Tell me, can we say minus 23 by 20?
Yes, ma'am.
Now write the right rational numbers which are in the simplest form. Otherwise, you'll have to simplify them. So don't write 22 by 20. Then you'll have to simplify. It's okay, you can write it, but go with minus 19 by 20. You understand why? Don't understand?
Yeah, ma'am. Yeah, understood.
Yes, ma'am.
Yeah. You can write minus 21 also. In fact, you can write minus 21 by 20. All right. Choose rational numbers which need not be simplified, which are already in the simplest form. So don't write 22 by 20 because you'll have to reduce it to minus 11 by 10. If you write it, reduce it to 11 by 10. So now that we have many numbers, we'll choose numbers which need not be reduced. That is, which are already in the simplest form. So minus 21 by 20, minus 19 by 20, minus 17 by 20, minus 13 by 20, minus 11 by 20, minus 7 by 20, minus 3 by 20, 1 by 20, minus 1 by 20, and 0 by 20 or 0. Then again 1 by 20. All these numbers positive you can write. All these numbers positive you can write. Minus 1 by 20, 3 by 20. Children, I'm sure you all understand well. So write any 10.
Yes, ma'am.
Yeah.
Yeah, ma'am.
The LCM of the denominators 5 and 4 is 20. So bring the rational numbers to the same denominator 20. Look at the numerators. Minus 24, 35. There is enough space. Now insert 10.
Do we have to do the other sub questions as homework?
Yeah, I think that'll be better. No, we can do something else. Yes. You can try the others.
Ma'am, should we
Please
try
write.
the others now?
No. We'll go ahead with something else. No.
So do we have to leave space or can we do it later?
That'll be better. No, that'll be leave some space. Yes. You can just gauge, no? Some
Ma'am, should we
for
do
three.
it as homework?
Yes, children. Yes.
Yes.
Homework. 1 and 5, we finished now. 3, 2, 3, 4 homework.
Ma'am, so we can leave an approximate amount of space and then carry on.
Correct. Yes.
Done, ma'am.
Okay. Yeah. Dash positive rational numbers lie between dash and dash. Dash and 1000. This is so big. Dash positive rational numbers. Oh. Okay.
All none.
All, huh?
Ma'am, I
Is
think
Z
all positive rational numbers lies between 1 and 1000.
all? So beyond 1000, there is no rational number, is it?
No, it won't be all.
No.
It's
It won't
infinite.
be all.
Okay. Infinite positive rational numbers lie between.
Ma'am, some positive rational numbers.
Some. Okay. You know what? Between 1 and 2 itself, there are infinitely many rationals.
Ma'am, we can write two positive rational numbers lie between 998 and 1000.
That's what I'm saying. See, between 0 and 0.1, there are infinitely many rational numbers. Between 0 and 0.1, there are infinitely many rationals. Please understand that. Because between 0 and 0.1, you know what you can write? You can write 0.01, 0.001, 0.0001, 0.0001, 0.00001, 0.000001. Tell me. Like this, you can write 0.0 between 0 and 0.1. I'm saying between 0 and 0.1. Okay, after this, you can write 0.02.
We can write infinite
0.002.
positive rational numbers lie between 0 and 1000.
Perfect. Infinite positive rational numbers lie between 0 and 1000. Why 0 and 1000? Because positive rational numbers. Positive. So to the left of 0 is all negative rational numbers. Between. Now, why 0? Why not 1? Because between, right? Between. So between means 0 will not be included and 0 need not be included because 0 is neither positive nor negative. 0 is neither positive nor negative. 0 is an integer. 0 is neither a positive integer nor a negative integer. It's just an integer. Infinite positive rational numbers lie between 0 and 1000. Positive rational numbers, right? So 0 and 1000. It starts only from, see, positive rational numbers start after 0. Okay, let me put it like that. Positive rational numbers, because 0 is an integer. 0 is a rational number. It's neither positive nor negative. 0 does not carry any sign with it. So from where do positive rational numbers begin? After 0, just after 0. 0 is neutral, neither
Yes, ma'am.
positive nor negative. So from where do we have positive rational numbers? Just
It
after
starts
0.
from 0.
Yeah, not 0. So after 0, that means it's between 0 and 1000. Okay. 15 by 2 is a rational number between integer 7 and
8.
8. Okay,
8.
children, I wanted to ask you this question. How many natural numbers are there? How many natural numbers lie between 4 and 5? How many
Infinite.
natural numbers lie between 4 and 5?
Infinite, ma'am.
Infinite.
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 Yes. Yeah, I want all of you to say that.
Infinite.
Infinite.
Yes.
All of you?
Yeah, ma'am.
Sure?
Yes, ma'am. Yeah, ma'am.
Yes, ma'am.
All of you are wrong. My question was, how many natural numbers lie between 4 and 5? How many natural numbers? Tell me one natural number between 4 and 5.
Ma'am, only one, ma'am.
Okay, tell me that one natural number between 4 and 5.
Oh, natural numbers. No, no.
Answer is none.
Yes, ma'am, none.
There is no natural number between 4 and 5. There is no natural number between 4 and 5. Tell me an integer between 4 and 5. An integer between 4 and 5. There's no integer after 4, between 4
None.
and 5. There is no
None.
integer between 4 and 5. Yeah, none. There is no integer between 4 and 5. So you should be very careful, children. See, what we just understood is there are infinitely many rationals. Between 4 and 5, there are infinitely many rational numbers. That means fractions, P by Q forms. But there is no natural number between 4 and 5. There is no integer between 4 and 5. After
Yes, ma'am.
4, yeah, the integer after 4 is 5. The integer after 4 is 5. There is no integer between 4 and 5. There is no natural number between 4 and 5 or between any two consecutive natural numbers. But there are infinitely many rational numbers between any two numbers. Even between the closest of the closest numbers like this, between 0 and 0.0001 also there are infinitely many rationals. Okay. 15 by 2 is a rational number between the integers 7 and 8. Because
7 and
15 by,
8.
yeah, because 15 by 2 is 7.5. So between the integers 7 and 8. 15 by 2 is 7.5. So between 7 and 8. Dash integers lie between -4 and 0. Yes, answer.
3.
Ma'am, is it
3.
negative?
Ma'am, 3.
-5.
Okay, Anantika 3. Somebody said negative. Who's that?
Shreya, ma'am.
Okay. Then Aishwarya -3. Yeah?
No,
No
I
problem.
said 3.
Who said 3? Anantika.
Aishwarya.
Aishwarya. Okay, Anantika. Okay, okay.
Ma'am,
Oh,
I
you,
already told 3.
oh, you already said 3. Okay. Sai Smriti, Aishwarya Shri.
3, ma'am.
Sai Smriti 3. Okay. So between dash integers lie between -4 and 0. 0 here. 1, 2. Oh, sorry. -1, -2, -3, -4. Between means you should not count this and this. And how many integers? 1, 2, 3. 3 integers lie between -4 and 0. Between, so you should not count -4 and 0. You should not count -4 and 0 because between. See, I'll write it again. Number line 0, -1, -2, -3, -4. Between -4 and 0. So not included, not included. Dash integers, not rational numbers. Integers only 1, 2, 3. 3 integers lie between -4 and 0. -3/5 is a rational number between dash and 0. You can give many answers for this actually. It's not unique, the answer. -3/5 is a rational number between dash and 0. There's no one answer for this. Children, -3/5 is a rational number between
-1, ma'am. -1 and 0.
-1 and 0. Yes, -1 and 0.
Yeah, ma'am.
Or you can say -4/5 and 0 also. So you can give different -2 and 0, you can say. -10 and 0. See, it's between that, right? Okay. Dash rational numbers lie between any two natural numbers. Between any two natural numbers, how many rational numbers?
Infinite.
Infinitely many. Rational numbers are infinite. Between any two integers or whole numbers, natural numbers, between any two numbers, there are infinitely many rationals. Infinitely many. Yeah. Yeah, children, you can take a screenshot now. Take a picture now.
Taken, ma'am.
Yeah.
Taken, ma'am.
Okay. Yeah, we'll discuss this one and wind up the session for today. Yeah, there are 5, 1 each. Somebody try the first one, another one, second, third, fourth, and fifth.
Mom, do we have to write this in our notebook?
Yeah, now we'll discuss the answer and then I suggest you write it in your book. You should, so that you can, revise later.
Yes, ma'am.
Yeah, anyone can try.
Ma'am, the first number one is B.
B. Between
Yeah.
any two given integers, between any two given numbers, we need not necessarily get an integer, but there will always lie a, any two given numbers they're saying. So even I go with B, rational number. There'll always be a rational number. You can't say if there's a natural number.
Ma'am, I have a doubt.
Yes.
Integer by integer is known as rational number, but it says it need not be an integer. If it was not an integer, how can it be a rational number, ma'am?
No. Between any two given numbers, we need not necessarily get an integer. Okay, see here. Now between say 1 by 5 and 2 by 5. Okay. Now 1 by 5 is 1 by 5 a rational number? 1 by 5 is a rational number. 2 by 5 is a rational number. Between these two rational numbers, 1 by 5 and 2 by 5, you cannot find a natural number. You cannot find a whole number. You cannot find a positive integer, but you can always find a rational number between these two. That's the meaning.
Okay, ma'am.
Between any two given numbers. So given numbers meaning they're rational numbers. Between any two given numbers meaning between any two given rational numbers. Numbers meaning rational numbers. See, when it's numbers, you cannot assume it to be whole numbers or natural numbers or integers. Any two numbers meaning any two rational numbers. We need not necessarily get an integer. Because every integer is a rational number, but all rational numbers are not integers. So,
okay, ma'am.
Now between 1 by 5 and 2 by 5, 1 by 5 is a rational number, 2 by 5 is also a rational number. Now between these two, there is no natural number, there is no whole number, there is no positive integer also. Between 1 by 5 and 2 by 5, there is no positive integer, but there's definitely a rational number. So B, rational number. Between any two given rational numbers, how many rational numbers are there?
Ma'am,
Countless, ma'am. B.
Countless.
Ma'am, B.
Yeah, many. Which of the following rational number? Which of the following is a rational number between 1 by 4 and 1 by 2?
C, ma'am. 1 by 3.
1 by 3, yeah? Okay. Shreya, is it?
Yes, ma'am.
Okay. Excuse me.
Ma'am, Sai Smriti 1 by 3.
Okay. Yeah, others working on it? Okay. So 1 by 4 and 1 by 2. We need to bring them to the same denominator. 1 by 4 and 1 by 2 is when you multiply this by, you get 2 by 4. 1 by 4 and 2 by 4. Okay. So now between 1 by 4 and 2 by 4, 1 by 2, this is ruled out. This is ruled out. And 5 by 4 is also ruled out. Why? Because the value of 5 by 4 is beyond 1. The value of 5 by 4, sometimes you'll have to work it like this, children. See here. 1 minute. See, you know that 1 by 4 is 0.25, right? And 1 by 2 is 0.5. Now, this one is not possible. 1 by 2 itself is not possible between. Now, 5 by 4. 5 by 4 is more than, what is 5 by 4? 1 by 4. 1 by 4. It's more than 1. It's not between 0.25 and 0.5. It's more than 1. You see that. 5 by 4 is 1 by 4 as a mixed fraction. It's 1.25. It's not between 0.25 and 0.5. Not possible. 1 by 3, you know, is 0.3333. 1 by 3. And yes, that is between 0.25 and 0.5. What's 2 by 3? It's 0.6. It's a simple division. 2 by 3, 0.66. That's beyond this, 0.5. So 1 by 3 is the correct answer. 1 by 3 is the correct answer. Two by 3 is 0.6. Simple division, 0.6. So it's not 0.6 is not between 0.25 and 0.5. It's beyond 0.5, 0.6. So this is not possible. 5 by 4 is more than 1. 1.25 it is. It's more than 1. 1 by 4. This is only 0.25 and 0.5. So this also is not possible. This is not possible. This also no. And if you try this, this is 0.3. Yes, 0.3 is between this. So 1 by 3 is the right answer. Yeah. Children, since it's time, you please try this one. I'll answer the last one for you. So which of the following statements is always true? So always this is true. Always, see here. When you have two numbers A and B, when you have two rational numbers A and B, their difference divided by 2 need not lie between them. You can just take an example like this. Say 10 and 5. Okay, two numbers 10 and 5. What's it? Consider two numbers 10 and 5. What is their difference? 5. Divide by 2, 2.5. Does this lie between 10 and 5? No. Let's take the numbers 10 and 5. 10 minus 5 is 5. 5 by 2 is 2.5. And 2.5 does not lie between 10 and 5. Similarly, A into B by 2. Take the same two numbers 10 and 5. What is 10 into 5? 50. 50 by 2? 25. And 25 does not lie between 10 and 5. Consider two numbers 10 and 5. Their product 10 into 5 is 50. By 2, 25. 25 does not lie between 5 and 10 or 10 and 5. Then A divided by B. So 10 by 5. 10 by 5 is 2. 2 by 2 is 1. And 1 does not lie between 10 and 5. But if you work this one, A plus B by 2, for the same two numbers, 10 and 5, 10 plus 5 is 15. 15 by 2, 7.5, which is clearly between 5 and 10. So A plus B by 2 is always true. This is always true. Which of the following statements is always true? A plus B by 2 is a rational number between A and B is always true. Not true. These are not true. This is always true. Please work this yourself. Homework. This one is this, and this. Yeah, children, take a screenshot.
Yes, ma'am.
Yes, ma'am.
Taken.
All right. All right, children. So next class we'll finish this chapter rational numbers. I just have a little more to do based on the properties. Simplifying expressions using the properties, mostly the distributive property of multiplication over addition and subtraction. So we have just that part remaining, simplifying expressions using the properties of rational numbers. We just have that and some verification, verifying, the commutative property, associative property. That'll be too simple for 8th standard. So that's all we have. So next class we'll wind up, meaning wrap up this chapter, rational numbers, and we'll go to the second chapter. No, I don't know what the next chapter is.
No, I
Oh,
think
linear
it's
equations.
numbers and sequences.
No. Linear equations. Who said numbers and sequences?
Sai Smriti, ma'am.
Which book does your school follow?
NCRT.
I don't see numbers and sequences in that. Not your 7th standard, you're in 8th standard now. Linear
sorry,
equations,
ma'am.
linear equations in one variable.
Yes, ma'am.
No, from where did you read that? Numbers and sequences?
No, ma'am.
Google,
I
huh?
just saw the. No, ma'am. I saw my book and I thought that was the next chapter.
No, linear equations in one variable. All right. So I will be covering the topics in the same order as it appears in NCRT. But this chapter, mensuration alone, perimeter and area, that alone I'll probably start off around June or July, because we need to revise that many times. So mensuration, the basics you learn in 8th standard, and then a little more in 9th, and more than that in 10th standard. So that we need to really revise a lot. So if I do that towards the end of the year, it actually is, towards the end in the textbook, in the list of contents, but that's not the right time to do mensuration. So mensuration, I will start off, maybe I'll finish the first 4 or 5 chapters and then do mensuration. That's the only chapter which I'll not do in the order. The rest of the chapters I'll do it as it appears in the NCRT textbook. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Good night, ma'am.
Good night.